good morning, afternoon, and evening, whatever the time of the day is that you get to see this video. I'm going to be working on activity 4 with you. So, doing engineering drawings. I'm going to show you some examples of that, and we'll work on each bullet point as we go down the list. Like, the best person to draw your concept is you, because you've got it in front of you. Okay, so all I'm going to do is show you examples of what engineering drawings look like, assemblies, blah blah blah, and so on like that. Drawings are drawings, so it's only specific for the parts. So you won't need annotations like you did have for activity 3, where you've done your concepts and we had to explain how this goes together and blah blah blah. You've done that bit now. You now need to do the drawings to make that happen. So far so good. So let's get back to, we're going to kick some more ass on this one and get on with it. Right, back to the nitty gritty. Here we go. Activity 4, develop a modified product proposal with relevant design documentation. The first bullet point is the proposal must include a solution, including a final drawing. Okay, now this could be multiple drawings of little bits and pieces, or you do one main assembly. As I said before, drawing's a drawing. You will not need the annotation like you did do for the concept designs. This is coming down to, this is what this material is made out of, this is the size of this is where this hole is, this is how it goes together, and so on like that. So I'm going to give you some examples of what these look like, and here is the first one. If you're struggling with drawings, these are the examples of what they provide in your exam pack. Now, if you follow what they say here, show you here, they are quite simple. What annotation have we got here? Not much. It's just coming down to the size of the parts, position of the bits and bobs, and obviously if you look into the title boxes at the bottom of the drawing, tells you what material they are, and so on and so on like that. That's what engineering drawing is. Now when you come down to do the assemblies, you can do a full assembly as provided from BTEC themselves. So if it's good enough for them to show you how it is like this, it's good enough for you to produce it like that for them to see. Now, if you want to go a bit fancy, do some exploded views. Here's a couple. So this is the air engine that I do with my students here. We have the first part, how this part goes together, and then we have the second part where that part goes onto the main assembly on the base, as you see there. We also have a it's quite relevant for the work platform, casters. So here's an example of exploded view of the casters, and as well as a fully assembled view as we go from there. Now, when it comes down to cross hatching, now if you look at what BTEC provided, they got all different types of lines. If you are going to work to drawing conventions, then your cross hatching is only done at 45 degrees. The bigger the part, the space between the cross hatching is big. The smaller the part, the cross hatching space between the lines gets closer. Now, when two parts are next to each other or on top of each other, you always find that one cross hatching will be at one face, one direction, and the other cross hatching of the separate part will be at the second one. Only done at 45 degrees. Don't care what anybody else has said to you. 45 degrees is the standard, and that's as much as it goes. You cannot do it any old angle you want. It needs to be 45 degrees. 45 degrees is the standard drawing conventions for cross hatching. No other angle is allowed. The only thing you can change is the pitch, which is a gap between the lines, to demonstrate or to indicate separate parts, as seen in this image here. So hopefully that's helped you understand how engineering drawing is done. Unfortunately, with CAD, it does put you at a disadvantage, because if you've not done any physical hand drawings in your lessons, you're going to have to learn fast, okay? Hopefully your tutors have done a good job and shown you how to do drawings. Now, I do that with my students from zero drawing experience all the way through to dimensioning the parts, cross-hatching, blah, blah, blah. But with the use of CAD, you've actually got to the skills of producing engineering drawings for your 3D models. It shows you how to do it, and it automatically does it. Now you need to think how to do that for yourself on paper as we go from there. Now, I'm just going to go through the rest of the bullet points. If you like what you've seen on the video so far, smash the like button, help me out, grow my channel. I've got 559 subscribers at the moment. Well, you hit the subscribe button as well. That helps me out there. And a notification button as well. If you are doing a project, this might be the channel for you as well. Engineering project. Let's get back to the video, and we're going to go through the other bullet points as we go down that list. See you in a minute. Moving on to the bullet points for activity 4, existing products, as you can see here. What I'm going to do here is bring you back to your research notes. Photos of existing products. I hope you got those in your research notes. What constructions used, how they joined, are they painted, the general sizes, do they fit the bill, and can they be used to access the panel for this scenario? Are the NS safer? Now, that's quite a generic thing. You can use that on quite a few of these different types of bits and pieces. But your discussion points that you really want to work with is what you have researched, describe your examples, and can you cover each one of those bullet points that are listed above. If you can, you have got enough material there to cover existing products. Back to our bullet point list, we're going to move on to materials quite quickly here. So another image for you to take a look at. So this, for the materials I discussed with the students from the data sheets that they gone through, which material performed the best. Now you've had that in activity 2 on there, so you can clearly say that that's what performed the best. Now it did have a construction method. Which was it? Was it bolted or welded? Okay, think about the design. Was the material property the main reason it survived so long? Okay, now when you're coming back to what I've got on the board here is, could the other 2 materials be utilized with better design? That's a big thing, that is. Yeah, they failed because the design was poor. If it was designed properly, you could have utilized either one of the other 2 materials to perform better than it actually did on the test there. Obviously, on top of that, what properties were needed to be the best material? Obviously, it's got its operational properties. Also, for manufacturing, can it be bent easy? How much processing have I got to do to it for me to bend it without it cracking and something like that? Now, once you've digested all this, because you've written it down, you should be able to come up with a conclusion on this this small section. Which material will you be using and why? And that's it. You're discussing this. Well, basically, the solution that you've designed is using the material that you've analysed from the tests and from your research notes. That would be enough to cover this section on there. Again, it's not one of those ones you have to go through War and Peace. Moving on to manufacturing processes. This is a little bit tasty, this one, so bear with us. Watch the notes or listen to what I say. Now you get your chance to discuss the manufacturing processes you want to employ to make the parts for the work platform or anything that you're doing there. So easy one we're going to start here is we're going to look at the sheet metal parts, right? So obviously you're going to use CNC laser cut. It's the cleanest out of the lot. So CAM software requires you to have DXF files where the software can nest all the parts to get efficient use of the materials on a single sheet. So optimizes material usage, as it says there. Very little cleaning from this, and can be folded straight away after. Now the CNC processes, or whatever CNC processes that you do, are consistent. The quality and accuracy is key here. So you ain't got to worry about, oh, it's just a little bit over, a little bit under. It's consistent throughout, and plus it's time efficient. You know, you put the sheet in, the part comes out, and all the operators do is pick the parts out of the off the bed, as you've seen in the previous video for the research. The CNC brake press, well, if you don't have to clean them up, you can actually go onto the CNC brake press and bend the parts of what you need to use. Obviously, the tubes that I want to use for the work platform to go over the top as your rail, your safety rails as such, we're going to use a CNC pipe bender for that. So that's an easy one there. Now, we ain't finished there yet. So obviously You cut them out, you bent them, and all that business. It now needs to be put together. So I'm choosing to do welding for the majority of this. So it could be welded manually using a MIG welder. So that has a coil of material, which when heated up, they fuse the parts together with this filler rod. 1,000 assemblies is normal for a specialist welding company, so don't worry about that. They will be able to do it, but you may want to employ a robot welder to do, as I said before, the bulk of the welding. And but as I say, the only drawbacks to here, it can be expensive, but may pay off for the time it saves as well. So you need an operator to do that. Now, coming down to the assembly, the 1,000 off batch is far too small to be fully automated. So you would use cells to make these parts. So after being cut, you feed the parts into the assembly cell. Once they've completed the parts from that cell, then they're going to be moved on to the next section. It might be where it needs to be powder coated, spray painted, whatever it is you choose to finish it off with. But to say, if you do it in cells, as you make the parts, as you finish the parts, they can go out to your suppliers or your customers. They go. You won't be making 1,000 parts and storing them, waiting for the customers to come and buy them. You make them to order. So if you make them as we go along, can make sure that you as you cut the parts, put them together, weld them up, get them sprayed, get them shipped out, and it's easier to take control of that. Now, if nobody wants it, you should just stop production. So here we go, back to the list again. We're going to look at sustainability, that old chestnut. So there will be quite a lot of differences on here, but I'm going to keep it as simple as I can. There are 3 main parts we need to deal with. Let's talk about this. First of all, what does it actually mean? Well, as I said before, it can be all different things. We keep it simple to renewable, biodegradable, and recyclable. Okay, so if you go for renewable, if it breaks, do you need to replace the whole thing? Or can you just replace the worn out parts? As I say, the wheels end up getting broken, blah, blah, blah. Rollers will get broken. Handrails might break, so they're either repairable, which you should be, or you replace them. But if it's broken, you just repair it. Biodegradable is, well, let's look at this. End of life, what can you do with it? Some of the plastics takes hundreds to 1,000 years to degrade. What or how does your product perform here? Okay, you need to go and only you can tell the examiner about that. Recyclable, well, let's take a look at this. End of life. Do we let this just degrade, or can you melt it down and reuse again? The rubber wheels can be repurposed, but recyclable basically rots away. It cannot be recycled. Thermoplastics can be recycled. Thermoset plastics are not recyclable. They can be repurposed to do something, but you can't recycle them. Basically melt them down and do something else with them. All metals can be recycled. Lucky enough, some metals give a higher price for scrap. So the likes of copper, brass, lead will give you more money back when you scrap that off. So there's swings and roundabouts in how you want to deal with this one. Hey, nearly there. Got a couple more left to do, and we'll be finished. Now we're going to go on to safety here. And yes, there's a fair bit we need to talk about here. The safety bit is designing at risk before selling the product to the public, okay? Which means it needs to be used for its intended purpose. So, at home, anyone use a pair of pliers as a hammer and knock something in? Maybe use a kitchen knife to use as a screwdriver to change batteries and remote control. This is what we're talking about. So we're not going to use this platform to launch as a launch pad to jump into a pool. Okay, or into a ball pit, whichever one you want to do. Not going to overload it. So if it's made for 120 kilos, we're not going to put 300 kilos on it. Obviously, you're not going to overreach from it. So when using a ladder, you don't stretch out to the other side and then run the risk of falling off. When designing these products, you'll use guidance from the HSC. Okay, for this particular product, working from height and safe product standards. You know, that's what we have. That's what we need to do for this one. Ask yourself, how have we made this safe for manufacturing, product, and the user? Well, you designed it, so you're the best person to answer this. But when we look at manufacturing, Yeah, are the processes safe? Okay, so if you look at painting and welding, you definitely need extraction. There's something on health and safety on that one there. Manual handling of the parts compared to the full assembly. So do you use a trolley? FLT stands for forklift truck, or you can conveyor them in. The welding, well, obviously you need a different set of PPE for the welder. Also, you need to protect anybody else in the area, so you use curtains to stop others being exposed to the welded arc. When assembling, do you use jigs and fixtures to make assembly easier? This also acts as less exertion for the employees when they put the thing together. Let's move to the product. Okay, so obviously if you have a higher safe working load, you include a safety factor. So if you make it to hold 150 kilos, you obviously want to make it hold at least 250 or 300. You double the safety factor. So our 70 and 90 kilo loading on the testing, not really high enough. We're going to include a higher safety factor on there. Stiff construction, well, that's what the customer wanted, so give it that. Obviously, braked wheels, stop it moving when you're actually on top of it. So nothing worse than you're trying to work out height and the thing underneath you is moving away from you. So obviously, you're going to be worried about that. Obviously, on this, included on this, we use grip tape on the top, like you'd use on the skateboards to stop you sliding off the surface. We added steps and handrails to the product because we want to make it safer for the user. Now, the user will not have to worry about the flimsy construction because we made the product stiffer. Easy to move and lock off because we have the braking wheels. We've got the grip tape on the top to stop you slipping. The handrails to stop the user falling off by accident. There's nothing worse than that. And obviously steps to make it easier to mount on the top plate. Now, when you are mentioning HSE Health and Safety Executive Guidance, you can refer to that on the relevant parts. Don't go for Health and Safety Work Act. That's just a cheap shot. You're not relevant because, as I said before, it's an umbrella act where everything goes underneath. There's an act for something. There's a guidance from the HSE. If you follow that, you can't go wrong. So make sure you discuss that as well. Last bullet point on the activity for other relevant factors. So what I do is return back to me. So here I are again, coming towards the end of the video. Don't switch off just yet. So other relevant factors. Now, depending on what they've written on the exam paper, you need to discuss that. Now, that would have been other relevant factors that you picked up on your research notes. Okay, so if you've got some decent topics you want to discuss there, bang those in. Okay, now again, please don't be wishy-washy on anything. Don't waffle. Be to the point. You are doing some sort of report here, and we'll go from there. Right, now the last video will be out tomorrow. Now, if you are doing 2 2-hour sessions tomorrow, you would only be at the end of the day just starting or an hour into activity 4. So this has come out in very good stead. If you have 2 2-hour stints on the Tuesday, the last video will be done tomorrow night, so it's all ready for you. Okay, so give you something to look forward to watching on the bus on the way in. Make sure you got your earbuds fully charged and a decent charge in the phone to give you a chance to watch that on the way into college or school, whichever way you're doing it. Okay, now ciao for now. Next video will be out tomorrow night. If not, this is you are in the future, then you'll find this on the playlist as you see there. Number 4. Yes, number 4. Right.